Thank you very much, and I have to apologise or poke Vince for saying the next speaker was going to be providing drinks. Well, unfortunately, that's not me, that's the one after me. So thanks to the HBF pass, Vince. How does this one work?
Just forward or backwards on.
Okay. Rule number one is always make sure you know how to work the thing. We've been in the lithium space now for about 2 years, or the pegmatite space, and the first time we went out bush was Nigel Brand, who many of you know, and I. And so we went out and found ourselves some pegmatite, and we had convinced ourselves that this is exactly what we wanted to look for. Took about 20 rock samples. That one there was the lowest lithium rock of all. I don't think we could have got a lower lithium rock if we'd tried. Anyway, we started drilling the pegmatites down on the Pioneer Dome, and just part of our pattern drilling, we encountered some caesium. We were invited over to meet some people in Canada at the Tanco Mine, because caesium or pollucite is only found in 2 other places on Earth. And one of the comforting comments that came from the fellow at Tanco was, if you wanted to buy their caesium formate, you wouldn't be able to afford it. So this is caesium formate. Well, if you drink it, don't go swimming afterwards. So it's got the same viscosity, same appearance as water, but it's got an SG of 2.2. So we'll get to that in a minute. Pioneer, many of you will know, we've been around for about 14 years. We're fairly Kalgoorlie-centric when we can be. So we try to stay within 100 k's of Kalgoorlie. In this case, the Pioneer Dome's about 180 k's, just north of Norseman. We also have projects in Canada. Wayne introduced us to some people in Canada that were looking for partners for a spodumene project over there. Very low geological risk, very good spodumene. But at that stage, that was it. And we've also got the mandatory project in the Pilbara. For those with a chemistry background, you'll remember the eastern side of, or the western side of your periodic table. Caesium is down there. And Mark Calderwood in particular this morning was talking about distance from granite stocks. We're of the same view that you need to be 3 or 4 kilometres out to find your spodumene zone. At this stage, at the Pioneer Dome, we haven't found any spodumene. We're drilling there at the moment though. What we do see is, if this is the idealised and very unlikely zoned pegmatite, we have these large ridges which look like very bleak quartz veins, but in fact they're probably silica gel cores of the pegmatites. And if we distill David London's work down, we have our wall zones and our intermediate zones, and then what struck us at the Pioneer Dome was these quite complex core zones right in the middle there. And in the core zones we tend to have lepidolites, the pollucites tucked in amongst there, these zones of silica. Apparently these can be high purity silica, so they do have some value down the track. Again, we haven't done the study on that yet. Then you come down into your wall zones where you'd expect to find your spodumene, and then your other zones down here, or intermediate zones and more. These are generally rocks from the Pioneer Dome, so shooting just quickly through the wall zones, the pegmatites that we're used to seeing, just about pure albite, petalite in that case. I've slipped in our Canadian spodumene there, and that's probably right. This one here I think probably should move up the sequence a little bit more. Then you get into your Clevelandites, your high purity silicas, and there's your pollucite there. And usually it's associated with quite high rubidium lepidolite. We've had Bill Ammon commenting about radiometrics. The image here is a uranium, thorium, potassium image, and it maps, in this case, the pegmatites very well. Other places it doesn't map them at all. Maybe that's a thing to do with potassium, or maybe it's a thing to do with cover. We're not sure. Now, the model is that we've got our peanut-shaped S-granite there, and we've got the pegmatites in amongst the ultramafics and sediments, etc., along there. Peg 8, which is that little bit there, is that little dot there. We've poked a few holes into Peg 1 and 2. We think we're too close to the granite in this case, and they weren't prospective. We've just done some drilling at Peg 3, and we've certainly seen zonations. We haven't got any assays back yet. And again, we're drilling at Peg 8 south now. And apparently we've got some beautiful rubellite, tourmalines, and well, our female geologist has said is the green clear stuff emerald. Well, probably inside the pegmatite it's not, but if it's on the margin of the pegmatites, it probably would be emeralds. So things are looking quite interesting for Peg 8 south, certainly well differentiated. So a little bit about Pollucite, and Wayne was going to hand around a bit of Pollucite too. It's gone. I want it back. That's the only bit in Perth. It's very rare, that's the first thing. It's a zeolite, and it's formed in very extremely differentiated pegmatites. It's probably the last mineral. Caesium is incompatible with anything else, so it'll charge up in lepidolite to a point, and we'll have a look at a graph in a minute, and then it looks like it dissolves as pollucite. It's just the last thing that really crystallises, although the more we get into it, it looks like you have these silica gels and the lepidolites and the caesium, all as just sort of last gasp of the really differentiated core. And these are very different to the Pilgangora or the Mount Marion pegmatites. Mark was talking about seeing some zonation down at Bald Hill, so he might be more into this area here, but from what we've seen, this is a pretty rare kind of beast. Maybe those ones around Nepean, what is it, Lepidolite Hill out of Coolgardie. There's a smattering, just some reports of individual crystals of pollucite from there. They are generally very small, and as I said, coexists with, doesn't matter, with petalite and silica. And as you can see, it's just a grey, translucent kind of thing with purple veinlets through it. I've got a chunk of rock from Tanco, and it's absolutely indistinguishable. Pollucite is known at approximately 110 localities. Now, this is Nigel Brand, who if you know him, he doesn't watch television, he just trawls databases and numbers and things like that. So these are his slides. 2 commercial zones, Tanco, which the original ore reserve, for want of a better term, was about 300,000 tonnes, and when it reconciled it was nowhere near that. Bakita, some of you might know more than me, but apparently initially 100,000 tonnes, but reconciled nowhere near that. Both of them are pretty much mined out, which makes our little 10,000 tonnes small, but significant globally. And of course it's Australia's first commercial one. This is a shot of Tanco. You have the, Bakita, sorry. That's the pollucite zone there. It's about 100 metres long, slightly less, but it's tucked in these really complex mixed core zones of the pegmatite. So petalite zones, lepidolite zones, mixed quartz zones, just a real stew. But then around them you have quite consistent zones of microclines and albites. Now, when we announced our discovery, we were bombarded by people saying, why are you looking for caesium? There's 10,000 years of supply of caesium in the world. And I'll be able to say, well, that's what happens when you look on Wikipedia, or you go to the first reference, not the second reference. Prior to 1998, there was no real use for caesium. In 1998, they invented caesium formate, that bottle that was going around. It's used as in high pressure, high temperature drilling, as a drilling fluid. It's clear as opposed to barite, which will block up everything. It's non-toxic, it's benign, as opposed to, zinc bromide, which will take your skin off and eat you through to the bone. And it will knock off 2 or 3 days of a drilling time of a drill hole in the North Sea. So we refer to the first slide. If you wanted to buy caesium formate, you wouldn't be able to afford to buy it, but 2 or 3 days off the cost of a drill hole in the North Sea will more than pay for the rental of the caesium formate, because what Cabot will do is rent you it. If they think you're going to lose it, they won't rent it to you. So they want to see 85% of it back. One of the colloquial stories that we heard was that if caesium formate was being used, the Deepwater Horizon disaster would never have happened. We heard that BP or Schlumberger tried to buy Cabot's entire stock to try and staunch the flow of that. Anyway, that didn't happen and we saw the result. So we think all of this is, well, Cabot won't tell you anything about it. We think that about 18,000 tonnes is turned into caesium formate a year, which is just to replace the stuff that is lost. And so they'll rent it to you for 180 days, you return it, they purify it, charge you for what you lose, and then rent it to somebody else and make north of $40 million a year for it. So that's our caesium formate. Mark Abani talked earlier today. He made us that. We've got the opportunity to play a couple of businesses here. We are getting lepidolite, so of course we've spoken to Lithium Australia and Lepidico, and one of the two bench samples or bench runs that Mark referred to earlier today was of our stuff. So we can proudly say we're one of the few Australian companies to have Australian-made lithium carbonate from Australian rocks. I don't think anybody else can say that. So we went and watched them make it, which was fine, and we said, that's exactly the same flow sheet as making caesium formate. Just take all the complicated bits out, and it's the same as the patent that Cabot had for making caesium formate, which fortunately expired 2 years ago. So we took around a bag of Pollucite, and we used the front end of the LMAX plant, dissolved it in sulfuric acid, and a couple of days later, Mark comes around our office and says, David, we've got a problem. And I thought, here we go, he's going to squeeze me for some more money. And he said, this stuff is just too easy to make. He said, you hit it with sulfuric acid, it goes into solution, your quartz, your silica, your lepidolites all come out at the first screen, neutralise it with a bit of limestone, add some formic acid, and you end up with a bottle of caesium formate, such as that, well, exactly that one that's going around. So he said, if there's more caesium, everybody will be making it. And no, pollucite isn't radioactive. Radioactive caesium comes from nuclear reactors. Because we're at a conference about battery and strategic metals, the highlighted ones are battery and strategic metal uses of small amounts of caesium. Probably 90% of the world's caesium goes into caesium formate. 10% of it from Tanco goes into chemicals, and whatever comes out of Bakita goes into chemicals. We understand about 5,000 tonnes comes out of Bakita periodically, meaning every 2 or 3 years. So the chemical business is several thousand tonnes a year, tops. But, Photoelectric cells, there's some improvements. It does get into batteries and things like that. Quite interesting reading once you get into it, but remembering it's all research level because there's so small quantities of this. This is our little deposit. It's a bit over 100 metres long. It's tucked in amongst some quite high-grade lepidolites. The average grade of our lepidolite is 2% lithium oxide. We've got some very good tantalum numbers in there, 3s and 400s. We've got petalite forming down here. So far we've only identified one crystal of spodumene, but we live in eternal hope. But at the moment this is only 200 metres out of a 10-kilometre long strike. And of course there are our caesium numbers there. And our geologists, you've got to, I suppose, forgive them for not recognising pollucite, seeing as nobody else had ever seen it in Australia. And when you're drilling white on white, there's your silica, there's your pollucite, there's your petalite, and back into pollucite. Good luck. Good luck trying to tell what's happened now. Okay, so another of Nigel's slides. We have the standardised model of, as you get away from your S-type granite, you have your different zones within your pegmatite, and your petalite your pollucite should be right on the outskirts of it. If we look at caesium, potassium and lithium, these are your general spodumene pegmatites sitting here. These are your lepidolites out here, and interestingly, it looks like they charge up in caesium to about just under 1%, and then it's just like a knife edge. And we've done this with several different ratios. And then your pollucite plots out here. So this looks like it's fully charged, saturated, and then your pollucite exsolves. These ones here are sort of where an RC rig has tapped 1 metre of pollucite and 1 metre of something else. Similar plot, this time caesium and rubidium. Your spodumene pegmatites plot here, and then you have your undersaturated whatnot, and then your pollucite is evident there. And this is the kind of stuff that we're trying to work out, to identify these points to see if they are a vector for the next caesium discovery. And the way we're doing that, again, we've got our long game has to be lithium, because, well, here we go. David London said to me on the phone, he said, if you've got 1 atom of caesium, you should have 10 atoms of rubidium, you should have 100 atoms of lithium. So therefore, if you've got 10 times the grade of caesium, your lithium target should be 1,000 times as big. So I'd like to do the easy thing and find something that's 1,000 times bigger than the second prize, which is the pollucite. So from an easy point of view, we've got these indices. So lithium and 2 other LCT elements, we rank a 5, a 4 if it's a lithium and something else. So that's probably going to be where your spodumines are going to occur, or your petalites. 3s are probably where your non-lithium LCT elements are going to be. And when we look at that, we start to see our Pioneer Dome generally looking like it's differentiating in this direction. So the highest rank for caesium is at this end, and coming back into lithium this way here. So the Sinclair zone is there. This is Peg9 is one that we joint ventured with Lepidico, so that's where the lepidolite came from that made the lithium carbonate that we referred to for the LMAX test. And away we go. Some of the other stuff we do, we use an XRF on everything. We try and keep it absolutely crystal clear. That's about XRF number 5, Wayne. We've worn out 4. We XRF absolutely everything. That's a Brooker, and this is the caesium elite frog image of that from our drilling. The other thing that we're playing around with at the moment is a Raman. One of the tough things is if you're on an RC rig and you've got white on white on white and trying to sort out what's what, is how can you tell on the trot? If you've got lepidolite in some elements, the XRF will help you with rubidium and a few things like that, but it won't help you with lithium, it won't help you with sodium. The Raman looks like it works quite well. It'll pick spodumene from petalite, from quartz, from albite, from microcline. All of those it can pick quite happily on the trot. So we've had it in the yard, obviously, doing our core. We haven't got it on the rig at the moment, although I would love to have it on the rig at the moment. So that looks like it's the way of the future as far as not having to wait months and months for your XRD data to come back. Now, I was at this presentation last year thinking that we're fairly smug. We'd just come back from Tanco, and reading Dr. London's book, at the end of the day, in his summary page, in his corollary, it sort of says the number of pegmatites where the mineralogy, chemistry and structure is well known is 1, and that's Tanco. So us trying to make generalisations about pegmatites is a bit of a nonsense, but we are all learning very, very fast. Already we are starting to see 2 kinds of LCT pegmatites, the ones that the fellows from Pilgangora and Mount Marion were talking about this morning, where it's wall-to-wall spodumene, and our one in Canada is in that. We have these very differentiated ones. Tanco's the extreme, Bakita is into that camp as well, and the Pioneer Dome falls into that camp as well. We hope as we come back we will have that spodumene wall-to-wall, but we haven't got it yet. I should say, though, that both Tanco and Bakita did have plenty of spodumene. So, 5 minutes to go. Oh, easy, easy. So let's have a quick look at Canada, and that's what a tray of wall-to-wall spodumene looks like. These guys were pretty happy. They finally saw some zonation. They couldn't understand what we were talking about, zonation. There's a little bit of albite in there, but otherwise spodumene to spodumene. Beautiful stuff. We hope to be drilling there again in January. What do they say? When it's frozen good. And we can't not have a cobalt project, just like we can't not have a Pilbara project, but I won't bore you with the Pilbara project. The Blair nickel mine was a counter-cyclic investment that we made, and it's still sitting in the counter cycle. So we did a swoop through the database, and these cobalt numbers, needless to say, are pretty handy ones. So we'll be starting drilling there later this week. In a previous life, I was exploration manager at Heron, so the Ardea cobalt laterites I'm pretty familiar with, and these are very, very similar to those. So they've got a market capitalisation of $150 odd million, so there's something missing out of our market capitalisation at the moment. There's some comparative grades, and these are just a random selection of ours. And that's it.